Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study about analog multimeter. We will study its construction, its principle of working, and we will see that how the analog multimeter is used for the measurement of voltage, current and resistance. So let us start with our topic. Analog multimeter is most commonly used by engineers and technicians in the laboratories and for the repairing works. Now this analog multimeter, as the name suggests, that it is a multimeter. Multi means that many and meter means measurements. So this analog multimeter, it is an instrument which is used for making multi measurements. Okay, means various types of measurements can be done with a single device. Now these measurements include the measurement of voltage, current and resistance. So analog multimeter can measure voltage, current and resistance of various ranges. So that is the definition of a multimeter. Now multimeter, they are of two types: digital multimeter and analog multimeter. The difference between these two multimeters is that digital multimeter is going to give us the output in the digital form, whereas the analog multimeter gives the output in the analog form. So digital form means that we will be having the digital reading over an LED or LCD. The digital output will be displayed. Whereas analog output means that we will be having a pointer. Pointer will be moving over a scale. On the scale we will be having divisions, and with the help of reading that scale we can get the output of the instrument. So here the output is an analog output. So there are two types of multimeters, and here we will study about the analog multimeter. So analog multimeter, it also measures the voltages, currents and the resistances. Both like DC and AC measurements can be done. DC and AC voltages plus DC and AC current can be measured with it. So for both DC and AC measurements, these multimeters are used. Now we know that for the measurement of voltage, the instrument which measures voltage is called the voltmeter. The instrument which measures current is called ammeter. And the instrument which measures resistance is called ohmmeter. Because voltage is, the unit for voltage is volts, the unit for current is ampere, and the unit for resistance is ohms. So based on that, instruments are called voltmeter, ammeter and ohmmeter. So because this multimeter, it is measuring the voltage, current and resistance, so we can say that it is a combination of voltmeter, ammeter and the ohmmeter. So it is sometimes also known as AVO. A for ammeter, V for voltmeter, and O for ohm meter. So analog multimeter can also be called as an AVO meter. Now let's come to the construction and principle of working of analog multimeters. An analog multimeter is basically a permanent magnet moving coil instrument. Or we can say that it is a galvanometer which is of PMMC type, that is permanent magnet moving coil type galvanometer. So analog multimeter is basically a permanent magnet moving coil galvanometer. So in this galvanometer we will be having a moving coil, and this coil is moving in the magnetic field of a permanent magnet. So the main parts of this galvanometer are the coil and the permanent magnet. This coil is wounded on an aluminium former. And because this coil is wounded on that aluminium former, and this former is allowed to move freely in the magnetic field of the permanent magnet. Now when current is passing through the permanent magnet, magnetic field is generated, and in that magnetic field the coil is being rotated. Okay, now to this coil a pointer is attached. Okay, so because the coil is moving in the magnetic field, so as the coil moves the pointer is also going to move. So pointer is attached with the coil, and because of the movement of the coil the pointer is also moving, and this pointer moves over a scale which is calibrated to give us the readings for the voltage, for current, and for the resistance. So if we talk about the main components of the analog multimeter, then we are having a coil, a permanent magnet, an aluminium former on which the coil is wounded around it. Then we are having a pointer, and pointer is moving over a graduated scale. So these are the main parts of the analog multimeter. Let's see its diagram. So this is the construction or the diagram of the analog multimeter, which is a type of permanent magnet moving coil galvanometer. Here these are the two north and south poles of the permanent magnet, and in between these, because in these poles here a magnetic field will be present, and in this magnetic field an aluminium former is present. Around this aluminium former the coil is being wounded. This is the coil, and to this coil a pointer is being attached, and this pointer is moving over this graduated scale. Okay, so due to this magnetic field of this magnet, the coil is going to rotate and pointer is attached to the coil, so coil is also moving to on the scale. So on this way, through this scale we can get the readings, and because we are getting the analog output, a pointer is moving and it is an indicating type of instrument. The pointer is going to indicate the values, so this is the analog output of the instrument. So this was the construction and working principle of the analog multimeter. Here you have seen that the galvanometer, because in the permanent magnet moving coil instruments, there should be some controlling torque and damping torque to be provided, so that when no input is being given to the instrument, the pointer should rest at the zero position, and as soon as the input is being removed, again the pointer comes to its zero position. So controlling torque and damping torque are provided here with the help of the jewel springs. Okay. So in this analog multimeter, there are two spiral springs which are attached to the coil assembly, one at the top and the other at the bottom. So these springs are going to provide the controlling torque. Controlling torque is needed because as soon as the input is being removed from the instrument, the pointer should return immediately to the zero position. So the returning back of the pointer to zero position is done by this controlling torque. Okay. Now let's see that how this analog multimeter, it measures the voltage, current and the resistance. As I have said that it is basically a permanent magnet moving coil galvanometer. So this galvanometer will be converted into voltmeter, ammeter and ohm meter for the measurement of voltage, current and resistance. So with the help of suitable circuits or circuit modification, the galvanometer is converted into a voltmeter for measuring voltage, an ammeter for measuring current and into an ohm meter for measuring the resistance. Now as you have seen that in that galvanometer we were having the scale from zero position to the maximum position. So this galvanometer is going to always have its zero position on the extreme left, and all the various measurements are done with respect to this zero position. So on the scale of the galvanometer you have seen that zero is present on the extreme left position. Here zero will be there. So pointer is going to give us the measurements by deflecting it in the right hand side directions. Okay. So now let us start with that how the galvanometer measures the voltage, current and resistance. First we will see that how the voltage is measured with the help of the analog multimeter. Now for voltage measurement, the galvanometer is to be converted into a voltmeter. So for that, small resistances are connected in series with the galvanometer. Okay, according to the range of voltages which we want to measure from the multimeter, according to that voltage value, the resistances are connected in series with the galvanometer. So voltages are measured by adding the resistances in series with the galvanometer. If high voltages are to be measured, then high resistances are connected. If low voltages are to be measured, then low resistances are connected. So according to the range of voltages measured, the resistance range is also varied. Let's see the circuit for it. So for the DC voltage measurements, this is for DC voltage measurements. We know that V is equals to IR. Okay, this is the Ohm's law. So voltage, it varies, means it is linearly related with the resistance. Okay, if we keep the current as constant, if we are changing the resistance value, voltage is also going to change in the circuit. So here if we want to measure very high voltages, then resistance value is also to be increased. This is the galvanometer. Suppose we want to measure the voltage in the range from 0 to 10 volts, then only resistance R1 is selected. This is the range selector switch. So when low voltages are to be measured, this switch is at this position. If we want to measure the voltages higher than 10 volts and less than 50 volts, then we will include both these resistances R1 and R2. Now they will be in series with each other. If we want to measure higher than this, less than 250, then all these three resistances will be connected. In this way, the range, that how much range of voltage we want to measure, we are going to vary the position of this switch. Okay, for more than 1000 volts it will be for more than 500 and less than 1000 it will be in between this. Okay, so according to the range of the voltages measured, this switch position is being changed. So voltages are measured by connecting the resistances in series with the galvanometer. Now this series resistance is also called multiplier, because the resistance values is getting added and voltages are being multiplied here. So it is called a multiplier. So this series resistance can be increased, or the range of voltages can be increased by increasing the number and values of the multiplier. Now if we see this the analog multimeter, in that analog multimeter there will be two leads. Okay, One lead is red in color and other lead is black in color. So red is taken as for the positive connection and black is taken as negative or for the ground connection. So on that multimeter, we will be having two leads, red and black leads. So one lead is to be connected. So because we are doing the DC voltage measurement, so one lead is to be connected with the voltage socket and the other lead, which is the black for negative and ground, that will be connected with the common point. Okay, so this is for the DC voltage measurements. Now it can be used for the AC voltage measurements also, and for AC voltage measurements a rectifier is used. So this rectifier is going to convert the AC into the DC for the application. The circuit will be same, just with the after this range selector switch. Before that we will be having a rectifier. So AC will be converted into DC and then the voltage measurements will be done and readings will be displayed on the scale. So let's see circuit for this AC voltage measurements also. So the circuit remains the same. This is the rectifier which is going to convert the AC into DC. That DC will be applied to the galvanometer and resistances will be connected according to the range of voltage measurement. So when AC voltage measurements are to be done, then again we were having the two leads. Okay, one lead is connected with the common point and other lead is connected with the voltage selection range. And we have to put the knob on the AC voltage measurement so that AC measurements can be done with it. Now here we have seen that we are converting the galvanometer into a voltmeter for measuring the voltage. Now we know that whenever we are measuring voltage with the help of a voltmeter, we connect voltmeter in parallel with the device whose voltage we want to measure. So here also one thing should be keep in mind, that when we are measuring the voltage with the help of analog multimeter, then multimeter should be connected in parallel with the circuit, then voltage will be measured. So for voltage measurements, analog multimeter is to be connected in parallel along with the portion whose voltage we want to measure. And according to the range of the voltage measurements, the range selector switch is being connected. So that was the voltage measurement by the analog multimeter. Now come to the current measurement by analog multimeter. So for the measurement of current, this analog multimeter is to be converted into an ammeter. So to convert this analog multimeter into an ammeter, because we have to convert the galvanometer, same galvanometer is converted into ammeter for the measurement of current. So for that, a resistance, a small value of resistance is connected in parallel with the galvanometer. So when we have studied the voltage measurement by the analog multimeter, resistance is connected in series with the galvanometer. But here, for the measurement of current, a small resistance is connected in parallel with galvanometer. Why? Because we know that from the Ohm's law, V equals to IR, okay, and I is equals to V by R. So current and resistance, they are inversely proportional to each other. So if we want to measure a large value of current, we have to reduce the resistance. Okay. So as the current range which we want to measure from the multimeter is increasing, the value of the resistance which is connected in parallel, it's decreasing. Okay. So because this resistance is connected in parallel, so it is called a shunt resistance. And this shunt resistance, if we want to measure large currents, then its value is to be decreased. Let's see the circuit for it, how current is measured. So for measurement of current across this galvanometer, in parallel resistances are connected with each other. So R1 is less than R2, R2 is less than R3. Okay. So if we are measuring large value of current, like if we want to measure 0.25 milliampere, then the range selector switch is at this position. If we want to measure 10 milliampere, then range selector switch is here. If we want to measure currents which are between 10 milliamperes and 250 milliamperes, then we have to keep the range selector switch in between. If greater than 250 milliampere current we want to measure, then the range selector switch will be kept at different position. So according to the range of current which we want to measure, the position of range selector switch is changing. Okay. And as the current which we want to measure is increasing, the value of the shunt resistance is decreasing. Okay. These are the positive and the negative, that is the two leads of the galvanometer or the analog multimeter, and this is the DC current measurement. Okay. So for DC current measurement, we will be having the two leads, the red and the black lead of the analog multimeter. Red lead is connected to the circuit, okay, to the range selector switch, and the black lead is connected to the common point, and the range of the current which we want to measure, that can be selected with this range selector switch. So if we want to change the ranges of the current measurement, we can do with the help of varying the value of the shunt resistance. we are converting the galvanometer into an ammeter for the measurement of current. And whenever we are measuring current with an ammeter, it is always connected in series with the circuit. So here also, if we want to measure the current with analog multimeter, it is to be connected in series with the circuit whose current we want to measure. So that is how the analog multimeter, it measures the DC current. For AC current, again rectifier is used. Rectifier is going to convert the AC value into the DC value, and then the measurements are done. Now let's see that how the analog multimeter, it measures the resistance. Now again, the same instrument is to be used for resistance measurement. So galvanometer is to be converted into an ohm meter. So to convert the galvanometer into an ohm meter, to this galvanometer, an internal battery is connected. In series with the galvanometer, and also there is a fixed resistance and one adjustable resistance. So for voltage and current measurement, we were just adding the resistance either in series or in parallel. But for the ohm meter or resistance measurement, we have to connect an internal battery in series with the galvanometer. A fixed resistance and an adjustable resistance are also used. Let's see the circuit for it. So this is the circuit for the resistance measurement. You can see here we are having the galvanometer or the analog multimeter. In this analog multimeter, we are having two leads. One is the black lead and other is the red lead. So red and black lead, they are connected across the circuit whose resistance we want to measure. Along with that, we are having a battery. They have batteries connected. These are the fixed resistances, and there is one adjustable resistance to adjust the zero value in the scale. Because here in this analog multimeter, we are having an analog scale. A pointer is there which is moving over a calibrated scale. Now, by the Ohm's law, we know that V equals to IR. So for measuring the resistance, we have to keep the voltage and current across the circuit as constant. So these fixed resistances, they help in keeping the current constant in the circuit. And when current is constant, voltage is being applied by the battery, so we can measure the resistances. Now here you can see that for the different ranges of resistances we want to measure, the range selector switch is kept at different positions. Okay, so battery is providing us the voltage, current is limited by this fixed resistances, so with that resistance can be measured. So for 10 kilo ohm of resistance measurement, the range selector switch is kept at this position. For 1 mega ohm resistance measurement, the range selector switch is kept at this position. So according to that, current and voltages, they are varied in the circuit. Voltage is constant by this battery 3 volts, current will be varied. Okay, so what's the function of the fixed resistances? To limit the value of current through the circuit. And what is the function of the variable resistance R? It is used for the zero adjustments of the pointer. Now the black and the red test leads, they are connected across the circuit whose resistance we want to measure. Okay, now the current which is flowing in this circuit, it depends upon the resistance which we want to measure. So we can say that this scale of the analog multimeter, it is indicating us the value of the current, not the resistance, but we can calibrate it in terms of resistance so that we can directly get the readings of resistance from the scale. How we can do that? First we are going to make this current as constant through the circuit. When current is made as constant, voltage is made as constant, so the readings which the analog multimeter is showing us here, that will be the resistance readings. Okay, so whenever we want to measure any resistance, then the black and the test leads, red test leads, they are connected across that resistance, and the zero adjustment resistor, that is connected, so that the pointer is going to give us a zero deflection. Okay, now when this is zero, it means that the resistance across the test leads is zero. Test leads are short circuited with each other, and then current is measured, and this resistance is varied, so that here the value of current is zero. It means that the black and the red test leads, the lead resistance is negligible. Okay, it is zero. After that, when it is calibrated, then the circuit whose resistance we want to measure, across that the leads will be connected. So first the standardization or calibration is done so that the exact readings can be done, and scale of the pointer gives us the reading of resistance directly. So this is how the analog multimeter can be used for the measurement of resistance by converting the galvanometer into the ohm meter. Now comes to the sensitivity of the multimeter. Sensitivity is defined as the resistance value per volt of the full scale deflection. Means when the ammeter is the multimeter is showing us the full scale deflection, at that time what is the resistance per unit volt. Now sensitivity is very important for the analog instruments, because if the analog instrument is having very high sensitivity, it means that it is having very high internal resistance. So if internal resistance is high, then and sensitivity is high, means that very small amount of measurements can be done with it. So it is a very important parameter for the instruments. So high sensitivity means high internal resistance, and if internal resistance is more, it means that when this instrument is connected in the circuit, then this instrument is going to draw negligible current from the circuit. So no current loss will be there, and exact readings and accurate readings will be given to us. So correct measurements can be done if the instrument is having high sensitivity. Now if we talk about the sensitivity of analog multimeter, it is in the range from 8 kilo ohm per volt to 20 kilo ohm per volt. Okay. Now let's come to the advantages and disadvantages of the analog multimeters. Now analog multimeters, because they are having very high sensitivity, so if there is very small amount of current, then analog multimeters, they are going to give us a quick deflection with respect to the digital multimeter. Also another advantage is that all the types of measurements, they can be done with a single meter only. Voltage, current, and the resistance, AC and DC voltages, AC DC currents, they can be measured with a single meter. Also, if there is any increase or decrease in the levels of the signals, that can also be observed easily on this meter, because pointer is moving over the scale. So if there is any increase or decrease, the pointer is also going to deflect in the right hand side or in the left hand side direction. So increase and decrease can be easily observed. So these were the advantages. Now comes the disadvantage. The disadvantages of analog multimeters are that they are very bulky. Also, they are costly. Also care has to be taken, because on that pointer and scale, they are kept in a mirror, okay, so that the observer can easily read the mirrors, easily read the scale through that mirror. So carefully we have to handle it, because if the mirror is damaged, the instrument is going to get damaged. So maintain care has to be taken. Also, while taking readings from that pointer or that from that scale, the observer has to be very concentrated, because if the observer is going to take the wrong readings, then errors can occur in the measurement. So in analog instruments, there is a possibility that human errors can occur, because in digital instrument, direct reading is given. Observer don't need to take the readings from the scale, so their possibility of error is less. But in analog multimeters, possibility of error is more. Also, the movement of the pointer is slow as compared to the digital instrument. Slowly the pointer is going to get deflected, because when the controlling the torque is going to increase the level of the controlling torque, then only the pointer is going to deflect. So pointer movement is slow. Also, they are very vulnerable to the shock and the vibrations. If shocks and vibrations are present in the surrounding environment, then it is going to affect the readings. Also, these instruments are little bit inaccurate due to the presence of the Earth's magnetic field. The Earth's magnetic field is also going to affect the readings, so it is a little bit inaccurate instrument. So these are the disadvantages of the analog multimeters. Applications, we already know that it can be used for the measurement of current, voltage and resistance. AC and DC measurements can be done with it. So here in this video we studied about the analog multimeters. We saw that what is its working principle, its construction, how it is used for measurement of voltage, current and resistance, its advantages, disadvantages and its applications. So I hope that this topic is now clear to you. Thank you.